Right, morning guys. Welcome to another session. Hope you've all been well. So I'm not so sure if any one of you have been checking as far as your pass is concerned. We got our first task as far as network architecture is concerned due on Friday next week, which is the 4th of September. So I think it's imperative for us to have maybe a quick discussion on what's happening as far as that particular assessment is concerned, and then time permitting, move on to discussing topologies. So if you look at, if there's any change, please give me a shout in terms of what's happening as far as your assessment schedule is concerned. But this is what I've got as far as assessments for this semester is concerned. And if you can check correctly, the network architecture, the first task is due on the 4th of September, which is, like we mentioned a couple of moments ago, Friday next week. So we just want to have a quick discussion on what it is that is relevant, what it is that you actually need to undertake in this particular assessment, and then probably entertain any other questions should you need some kind of clarity or further clarity on certain things. But I think once we've had a quick discussion, you should be quite lucid in terms of what, or should be quite lucid in terms of what it is that you need to undertake there. So if you look at what we've got an actual POE that has tasks that are associated with your specific module there. I think we've got two tasks. Task one, which is literally the same thing as assignment one. Then you've got task two. And then naturally a couple of questions associated with what's happening as far as the actual POE is concerned. So these are the basic instructions associated with these are the instructions associated with your first task. So ultimately now you just need to understand or you just need to show some kind of understanding as far as demonstration of network acumen there is concerned. So ultimately you've got you needing to look at some kind of you needing to look at some kind of research associated with this particular assessment. So whatever you need to incorporate needs to have some kind of real life reference. So obviously you're looking at real components and architectures that are currently available in the marketplace. And then you need to provide some kind of judgment or advice, technical advice that you need to typically provide for in terms of what needs to be incorporated as far as the scenario that they've presented in this distinctive POE and task there is concerned. So obviously, you're not really required to design a complete network, but you're supposed to typically show some kind of understanding in terms of what is happening as far as basic and network architecture configurations there are concerned. So you've got three distinctive activities that are relevant as far as this particular task is concerned, and they've given you a time frame there associated with completion. So that's basic estimates: 2.5 hours for the first one, all the way down to 3.5 hours for the third activity. And you've got mock allocations that have been incorporated there. And you've got a rubric as well that has been incorporated as far as this particular assessment would go. So this would make it a lot easier for you now to understand exactly where marks are going to be allocated or what you're going to be typically awarded marks on. So it makes it a bit, I'd want to say simplified in terms of understanding exactly what's happening with the marks associated with a distinctive section there. So as you can see, activity 2 is your make or break there. It's very important for you to make sure that you undertake that particular activity accordingly, not to dampen or not to dilute the other activities that are incorporated there, but it's imperative for you to make sure that you add in as much relevant content for task 2 as necessary, because that's, to be honest, that would be your make or break question as far as the actual tasks they are concerned. So we've got a scenario that they've provided for. We've got a marketing company that you need to be working with there. And ultimately, currently, the company is sitting with about 10 odd employees, but they're looking for some kind of growth of between 15 to 20 employees as far as the next calendar year there is concerned. So ultimately, you've got an individual who's got some kind of knowledge as far as ICT is concerned. So they're looking for you to advise them in terms of how they can properly set up a network when they move to new offices, because ultimately, you want to then design something that is arguably future-proof, which means that you want to look at something that can accommodate for that growth that we mentioned a couple of moments back, and also looking at a scenario where you don't need to look at some kind of reconfiguration or acquisition of new tech dependent. So when you're looking at it from a technological point of view, I think we might have discussed this in Comp Arc before, that when you're looking at acquiring a certain piece of technology, so it could be a smartphone, it could be a tablet, it could be a laptop, it could be a desktop. Normally, when you walk in to a store, obviously you have already done your research, but you want to buy something that can accommodate you probably for the next 5 years. So you want to look at a processor that can accommodate for that time frame. You want to look for X amounts of RAM that would typically be applicable as far as your machining mechanisms there is concerned. You want to look at obviously a basic storage. So I think you can agree that there was a point in time where 4 gigs of RAM was something that was commendable when it came to basic computer systems or when it came to a laptop, but that is no longer relevant now when you look at the architectures that we're working with, and when you're looking at the actual things that you need to do with that distinctive gadget. If you look at most of you, you're going to be going into the development qualification next year. So ultimately, if you are in the market for a device, you need to be looking for something at a minimum, at least sitting with about 8 gigs of RAM, at least running a solid state drive of 512 gigabytes, at least sitting with if you're going to go with Intel Core i5, if you're going to go with AMD Ryzen 5 or Ryzen 5, whichever way you want to pronounce that one, is your minimum go-to. So this would at least accommodate for whatever it is that you want to do. It also will accommodate for that time frame that we were mentioning a couple of moments ago. Same difference would go with your smartphones. Listen, if you're in the technological framework, you're not really looking for something that is fashionable. You want to look at something that is functional. You also want to look at something that can accommodate you for that time frame, like I was saying earlier on. So it's the same thing when you're looking at this particular scenario, look at this particular environment where the specific network or the infrastructure that you are going to be advising on needs to be future-proof, which means that, or as future-proof as possible, so that it can accommodate for that growth that this particular organization is trying to look at. And you want to obviously minimize the amount of capital that is used on acquisition of this particular technology as well. So you've got an office space with at least 5 rooms, one large plan, one large open plan office with 4 smaller offices for the managers, and then you also have this particular building located in a business park. So arguably, you've got high-speed fiber incorporated there. And ultimately, this particular marketing firm is deals with a lot of multimedia data. So ultimately, the whole concept of marketing, remember, is dominated by the digital marketing and media platforms as far as industry perspectives they are concerned. So ultimately, you also have another individual there who's going to have some kind of expertise associated with web analytics. So you obviously need to take that into consideration when you're setting up the network. And then the last distinctive point there some staff will be using desktop PCs. Others have laptops, and most of them obviously will have Samsung tablets or iPads. I think that last part there is just mentioning that others would have some kind of portable devices incorporated there. So I think that the branding there is just for indication's sake, really, as far as your specific setup there is concerned. So that's the kind of scenario that we've got as far as this particular assessment would go. So when you look at the activities now, you've got basic definitions for the first one, because you now need to differentiate between Ethernet, token ring, fiber distributed data interface, your FDDI, and Wi-Fi. So you're looking at basic differences between these particular architectures, and then ultimately providing some kind of recommendation, which one would be the appropriate one to go with. So ultimately, again, like I was saying a couple of moments back, that you need to do the appropriate research that then would enable you to undertake this accordingly, to obviously make sure that whatever advice that you're providing for would be industry related and obviously current as far as basic technology there is concerned. So it's a 10-mark question. Ultimately, you need to obviously throw in as much distinctive content as relevant there, but obviously make sure that if you're looking at using material, obviously that is not yours, you need to then reference accordingly. I think I'm not going to waste too much time in terms of the referencing, because you are familiar with this. Is second semester now, so I think it's no longer alien culture there in terms of understanding exactly why you need to reference and how you need to be referencing. If you still have distinctive issues there, I think have a session with the librarian, or try and set up something with the librarian there to assist you as far as the whole concept of referencing there is concerned. So you're going to be looking at in-text referencing, and naturally have a bibliography page right at the end of your assessment there, or a reference page that will then list everything that you've used in alphabetical order, not essentially in the order that you've used it. So the Harvard referencing style there, just to remind you on what's happening as far as referencing is concerned. Please take this seriously, because remember, I think most of you have already experienced this. If you don't incorporate the correct referencing there, you could be disqualified for certain sections of your assessment or the entirety of it. So just make sure that you don't get lazy when it comes to appropriately referencing content that you provide for. Obviously, when it comes to the whole submission, you need to submit this through SafeAssign first, so that you get the originality report generated, and then naturally submit that report with the original assignment on Teams. I think we had certain instances where a couple of individuals have been submitting on VC Learn. Please make sure that you submit your assessment on Teams, to avoid that particular assessment typically being, we could argue that that particular assessment being misplaced, and obviously not being marked at the end of the day. So make sure you stick to Teams, guys. I think those links have already been uploaded. If not, they should be available for you before the actual due date of your assessments. So VC Learn, you'll use that for your SafeAssign. And then once the SafeAssign report has been generated, you then submit that generated report plus your original assignment or original submission on MS Teams. And then I think the other thing as well that you also need to make sure that you take cognizance of, I think we've mentioned this a couple of times before, is try and submit a couple of days before, at least about 48 hours odd, when it comes to the SafeAssign report, because normally there's a tendency of congestion as far as that particular platform goes. So try and submit at least 48 hours beforehand, so that you can have your report generated in time to avoid any distinctive discrepancies as far as submission would go. So that's your 1.1 day. 1.2, again, just a basic definition in terms of what's happening with how two distinctive computer systems connect. I think you'll discover that most of this content we've already looked at, especially when discussing the OSI model. as far as connection platforms they are concerned. So technically look through that and identify exactly what's happening, how you would have two distinctive computer systems within any given setup connect, obviously within a peer-to-peer environment, how would they connect or send data across any distinctive platforms within your network. 5-mark question there. Again, whichever research or whichever content that is used that you use that is not yours, just make sure you reference accordingly, and just limit it to 25% if you remember, just to avoid any kind of discrepancy. So question 1 really is not that much of an involving question, but again, can if you take it for granted, it can be easy for you to add irrelevant or incorrect information for this. So make sure for 1.1, you look at the distinctive differences, or you compare those 4 technologies that have been listed there, and then you provide a well-researched and well justified recommendation of what this particular organization or institution should be going with as far as those 4 technologies, or as far as one of those 4 technologies there is concerned. And then obviously 1.2, just trying to elucidate on what is happening in terms of how 2 machines that are connected typically send data across as far as your setup is concerned. So obviously the main focus there is obviously going to be on the Ethernet architecture there. So 1 is quite simple and straightforward. I think the same difference applies for everything else though. Or activity 2 now, on the other hand, requires you to use Microsoft Visio to create a network diagram. So you'll note there's a difference between a floor plan and a network diagram. I think it's imperative for us to clarify that, because your floor plan will normally show seating arrangements, will normally show the actual layout as far as your floor is concerned. So where the doors are going to be, where the windows are going to be, where distinctive structures are going to be incorporated. And again, like I said right at the beginning there, your seating plans and so on. But on the other hand, when you look at a network diagram, more often than not, this is more of a logical kind of diagram that shows the devices that are going to be incorporated and how these devices are going to be connected. So I think it's imperative, again, I think later on, like I said before, we'll discuss what's happening with topologies. For you to, we've mentioned these before, but I think we'll just delve into them again for you to understand exactly how you then lay out your specific network and use the appropriate devices within that network. So naturally, you'll need to incorporate your switches and your routers. Remember, hubs would be irrelevant because we're looking at an enterprise type of network, and hubs have got. We've mentioned discrepancies associated with hubs before. So your default go-to devices there would obviously be your switches and your routers, as far as basic connectivity is concerned. Ultimately, because you're also going to be looking at it from a enterprise or business type of setup, you'll naturally then would need to incorporate a server that will accommodate for those basic services that are relevant within any given network. So your print services, your web services, your application services, your file services, database services are all examples of what your server would typically provide for. I think we've discussed this before to say that, look, when you look at especially when you look at task 2, when you need to then install your own type of server architectures there, what you'll then need to do is typically make sure that when you install the softwares, you then add the distinctive roles, because just installing the server software is not enough. You need to then add the specific role that makes that server a DHCP server, that makes that server a DNS server, that makes that server a print server, and so on, as far as your particular setup there is concerned. I think we have...
I have a question.
Yes, I believe what's happening there.
Do we have to reference the diagram as well?
You have to reference everything, Avelino. Everything in an assessment, will always need to be referenced. So please make sure you don't miss that part. So everything in an assessment needs to be referenced to avoid any discrepancies there. And while we just took that question, I think I've got something here on chat. Keegan, you just asked with question 2, is there any other software which works like? Yes, you can use. There's another one called Free Draw. As long as so for this particular question, as long as you don't use the basics, like for instance, using triangles or using rectangles or basic shapes to represent devices, you'll be disqualified for the entirety of the question, guys. So don't go ahead and probably use Word and plug in a couple of triangles or shapes there and label them accordingly to say, okay, this is a server, this is a machine, this is a printer, and so on. Why? Because you need to be using the relevant software. So it's MS Visio that you need to go with, but ultimately you can also go with Free Draw. I think this is a free online package that you can use that has the relevant network icons that obviously would be applicable as far as the actual question there is concerned. So ultimately, it's not just Visio that you're limited to, but it's your default go-to if you want to look at it from a different perspective. But Keegan, to answer your question there, you're looking. I think you can use Free Draw as well, which is an online type of a software package that you can then use that has the appropriate icons that will enable you to reference the switch accordingly. For instance, that will enable you to reference the server accordingly, because it has the relevant icons that assist with that. So it's important to take cognizance of that fact there. So your basic network diagram, like I was telling you a couple of moments back, is all to do with the logistics in terms of how you would connect your distinctive devices. So if I was to show you, let me quickly see if I can show you a relevant image there associated with so we've got something like this. So this is a typical example of what a basic network diagram would distinctively look like. So you've got icons that obviously are there to distinctly represent the devices that you use. And again, like we've mentioned before, your switches and your routers become your defaults there. And you can also obviously incorporate the wireless access points associated with the devices that are portable within the network setup or the scenario that has been presented. Remember, you've got a couple of individuals using their tablets. You've got a couple of individuals obviously using their laptops. So wireless access points will obviously be relevant there for Wi-Fi access. And then naturally for the desktops or the rest of the machines there, you've got bounded architecture and media that you need to take into consideration. Ultimately, you will also need to probably indicate what would sit in the server room. So you got your servers, and naturally your basic networking devices like your switches and your routers that all sit within one distinctive room that then provides connectivity to the entirety of the office as far as your environments would go. So that's a typical example of what a basic network diagram would look like. Remember, firewalls are relevant because they provide some kind of security. And these particular firewalls can either be software or hardware based. Obviously, the best or the most appropriate ones would be a combination of both. And these particular firewalls typically filter traffic from within and from without your network to try and typically safeguard communications or safeguard network configurations across the board. That's a typical example of what your network diagram would look like. Something else that you also want to probably look at is something that mimics what you've got on the screen there, where you now have incorporated an actual legend that would typically indicate what each one of those icons would distinctly represent within your environment. So this is just a basic example of what a network diagram is all about. And I think you can then appreciate the difference I was mentioning earlier on between a floor plan and an actual network diagram, because the network diagram is just showing the logic in terms of how you're going to be incorporating devices, or how these particular devices are going to be communicating or connected, and obviously which particular architectures are going to be incorporated. And one of the other things as well that is relevant for this particular question is for you then to appropriately use the right IP addressing schemes. So remember, we've talked about IPv4 before. This should be familiar territory for you now, because we mentioned IPv4 in detail. We talked about the three classes that are applicable, which is class A, B, and C. And we've mentioned that for internal networks, ultimately, you've got private address ranges that were typically designed to accommodate for internal addressing architectures or internal addressing platforms. And ultimately, if you look at each one of those classes. So class A would have a private addressing range. Class B, on the other hand, would also have the same difference applies for class C. So when you are incorporating your addressing, make sure that you stick to within a specific class or within a specific range. You do not want a scenario where you plug in a private address from class A, and then one of the other devices is using a private address from class B. Then the other device is also using a private address from class C. Remember, you want to make sure that everything can communicate accordingly without any distinctive problems or issues there. Yes, we did also discuss NAT, that we mentioned NAT is an architecture that then hides internal addressing schemes from the external networks and so on. But in this particular setup, you need to then make sure that you plug in the right ranges. And in the example that we've got on screen currently, you can see that that's a class C private address range, and it's appropriate in terms of or it's been incorporated appropriately in terms of making sure that it's within a specific range. So we've got the 192.168.2 range. Everything else now in terms of the actual devices or the .2 network, because remember, when you look at your IPs that we mentioned before, you got a network portion or network ID and the actual host. So in this particular setup that we've got, our network ID would be 192.168.2, right? And obviously that 0. And then everything else in terms of the devices would fall within those specifics. So if you look at each one of those machines there, you've got .6, .202, .110, .33, you've got .101, you've got .1, and so on. But the network ID is 192.168.2.0. So that's what you need to take into consideration when you're ultimately incorporating the IPs for the devices that are there. Remember, they've mentioned a growth of between 15 to 20. So you're looking at a maximum, or you're looking at least incorporating devices that show the 20 devices that have been mentioned in this particular instance. And then you also need to add in other devices that will then enable this particular network to be configured and function appropriately. So it's not just a question of plugging in 20 machines in terms of a combination of the tablets, the laptops, and the desktops. But in order for those devices to function or connect, you obviously need to incorporate switches, you obviously need to incorporate your firewalls, you obviously need to incorporate your servers and your routers and your wireless access points that will then avail for connectivity to the network, connectivity to both internal network and external needs to be incorporated there. So please make sure you don't make the mistake of incorporating public IP address ranges for your devices, because remember, this is an internal network. You're looking at internal addressing schemes or private addressing schemes, and then ultimately you would then probably just indicate one public IP address that is configured server or router side, that will then enable connectivity to the internet. Because remember, we've mentioned before that internal addressing schemes are non-routable, which means that without architectures such as NAT, these particular addressing schemes cannot, or any device that will have these internal addressing schemes or private addressing schemes cannot then connect to external networks. And obviously our most common one when it comes to connectivity there would then be your internet space. So this is a typical example of what your network diagram should look like for that distinctive question. Again, make sure that you use the appropriate program. If I'm not mistaken, the FTP site on campus there should typically have your Visio loaded. If you cannot download, if you cannot access, it's just a question of searching Visio ISO on the net. You should find a couple incorporated there. It's just a question of downloading and installing. If you cannot still, give me a shout and then I'll just upload it on Teams there so that you can then download. I think the retail version that I've got is about 3.5 gig. And then that's the 2019 one rather. And then I think the 2016 is about 650 megs, if I'm not mistaken. So give me a shout if you have problems in terms of finding that software. I can always upload it on your profile directly, whichever way. All right, so that's the whole concept associated with the second activity there. As far as your assessment is concerned, I think if you go back to our questions there, you'll discover that excuse me. I think that the last point I was making there then obviously just covers the 2.2 as far as your specific setup is concerned, making sure that you put in the right addressing scheme for your network. So if you're going to go with the Class A's private address range, stick to that. If you're going to go with Class B, stick to that. If you're going to go with Class C, same difference applies. So just make sure that you get that incorporated appropriately without any distinctive issues. And then the whole concept of the server room, or the whole concept of basic location of devices that I was mentioning a couple of moments ago, would obviously then tackle or be applicable for question 2.3 there, where you now need to just explain why you decided to go with a specific type of router, why you've decided to go with your server platforms, why you've decided to go with certain devices, and where these devices are going to be located as far as your specific network infrastructure is concerned. So take that into consideration. So in essence, obviously, when it comes to things like your server room as an argument, you just need to then state that there is going to be a specific separate location that will house the servers and the equipment, and obviously why that is necessary and how you're going to be incorporating that as far as your network infrastructure there is concerned. 2.4, on the other hand, now is looking at basic pricing for the gadgets that you've got. So every device that you've got in your network, whether it's a tablet, whether it's a laptop, whether it's a switch, whether it's a wireless access point, and so on, you need to have a specific inventory of it that will then have specs associated with that specific gadget or device, as well as the distinctive local pricing. So this is rand value for this particular type of question. I think we've had instances where candidates will just find probably something on Amazon, or just want to find something generically on the net and just plug in pricing as is, with probably different currency formats there. But you obviously get penalized for that, for this particular type of question, because ultimately you need to be making sure that you're finding a local pricing for your device configurations there, and then obviously incorporating the relevant specs associated with your devices. So naturally, you can get quotations off the net there from several of these institutions that are out there that provide for these devices or services. You'll need to then plug that in directly into your assessment to show proof of the pricing and the specs that you've mentioned. So you might have probably a separate table or separate a section that will list your devices, give a description of the devices, give the specs of the devices, and then something else that is incorporated that typically justifies, or that typically provides proof of pricing, that provides proof rather of specs associated with your devices. So please make sure you do the applicable research for this section as far as your particular assessment there is concerned. All right. So question 2's main purpose is just to show your understanding, or to demonstrate your understanding of the networking devices that we've discussed before, and why you need to go with those devices, how you then link them up together, and obviously what type of topologies or layout or structures that you'd use to incorporate these particular devices, and make sure you plug in the devices that they've mentioned. We're looking at least 20 devices that are there, because remember, 20 user devices, like your laptops, your desktops, and your tablets, because naturally they've mentioned that there is some kind of scalability that needs to be taken into consideration, some kind of growth, some kind of future-proof mechanisms put in place. So they did give the 15 to 20, but at least you need to then plug in the 20 devices there to show that that particular network that you've chosen, or that particular network that you've configured, can accommodate for those devices and more, should there be a need for expansion as far as this particular institution there is concerned. So that's question 2, or activity 2, that will need a specific diagram, preferably in MS Visio, but again, there's free draw that you can use. But remember, I think that whichever platform or whichever program or software that you find, you need to make sure that the relevant icons are there, as I had initially shown you in the examples that we had for what a basic network diagram would distinctively look like. Make sure that you incorporate the right addressing schemes as far as your private address ranges they are concerned. And then ultimately also with these private address ranges, you incorporate the right subnet mask. Remember, we mentioned before that your mask's main purpose is to make sure that you distinctively identify which is the network portion of your IP address and which is the actual host portion associated with your distinctive IP. So you're going to go with A, make sure that you at least work with class A's default mask. If you have to reconfigure that, make sure you're reconfiguring it from class A's default mask as a typical example there. And then I think the other question that is also normally taken for granted there would be question 2.4, in terms of you making sure that you get realistic pricing, local pricing, and you incorporate the right specs for the devices that you've got incorporated as far as your network there is concerned. All right, so that's activity 2 there. Literally your make or break question, because if you don't tackle this accordingly, it can do you over in terms of final submission there, or your final marks, whichever way you look at it. And then the last question, more theory-based question again, looking at the actual need for devices having unique addresses, or devices having to have addresses within any given network platform. 3.2 looks at the OSI model. We've mentioned the data link layer versus the network layer. And if you remember well, we mentioned that your data link layer deals with physical addresses, normally when you're looking at basic configuration associated with your local area networks. On the other hand, we mentioned that IP addresses are ultimately logical addresses that then enable some kind of routing, or that deal with specific pathways that enable connectivity to external network architectures there. That obviously goes into 3.3 there, explaining how devices now on your network actually get these physical and logical addresses. With 3.4, definition of what's happening, or just a basic description of how packets actually traverse from one particular point to the other. And ultimately, you might want to also look at the data link layer of the OSI model, because this is where those frames we talked about before are introduced. The actual different parts of these frames would then enable you to understand exactly the necessity of these particular sections in terms of the way in which those packets are ultimately sent from source to distinctive destination there. And then lastly, something that we've mentioned in our very first lecture, we also mentioned it when we're discussing the IPs, what has been incorporated to try and circumvent the actual running out of IPv4 addresses as far as your particular setup is concerned, or to alleviate those distinctive problems associated with IP addresses distinctively running out. So I think ultimately that's the main focus there is what's happening to accommodate for the actual discrepancies now being experienced, or that have been experienced by IP version 4 or within IP version 4 in terms of those IP addresses distinctively running out there. All right, so that's your distinctive task 1 at large. Remember, task 2 would now be a bit more practical with your virtual server configurations and client connectivity. I think, if I'm not mistaken, communication should have gone out already as far as the campus is concerned, because I think we'll have a couple of face-to-face sessions on campus once a week, if I'm not mistaken, that will then enable you to undertake the physical part, especially when it comes to creation of your straight-through cable, that you'll then also need to test in terms of if it's working accordingly by plugging it into a switch that then is plugged to a basic computer system there. So that should be that as far as this particular assessment goes. I think it's pretty straightforward content, really. Do we have any questions from the floor there in terms of what needs to be undertaken as far as the first task there is concerned? Do we have any pertinent questions or contributions or concerns in terms of the first task there? Any questions there? Okay, I'm assuming the silence is consent, or you being content naturally. Okay, sorted. If you still have any issues there, just pop me a mail as usual. Then we can always attend it from that score. But try and get a ball rolling at least over this weekend, so that you can pace yourself accordingly as far as the actual assessment there is concerned. Okay, so that is that. I think what we can do now is just then briefly have a quick discussion on what is happening as far as your topologies are concerned. And then I think sometime next week, we'll also then continue with server-side computing, just understanding exactly what's happening with that before we start delving into the practical part of setting up your virtual machines. Right, so we want to look at topologies, right? So let's see if I can quickly all right, so Graham, just to attend to that question, getting different diagrams, how do you mean? Because I think I'm lost on that one. How do you mean getting different diagrams? Maybe you might want to elucidate on that question. So Graham, what do you mean by getting different diagrams? Yeah, so these you'll get these through Visio. So if I understood your question correctly, if you install Visio, Visio enables you to work to create a network diagram. There's already a template, or there are already templates that are there for you. Just a question of selecting a template, network diagram template, and then plugging in devices or clicking and dragging icons within that distinctive space to then enable you to create your network diagram. So remember, the Visio will then enable you to use icons that are distinctively representative of devices that are there. So if you go back to what I was showing you earlier on, maybe let me just quickly see if I can share this again, just to make sure we clarify on that. So if you go back to this here, this is from Visio. This diagram has been created in Visio. So all these icons that you see are part and parcel of the Visio program that then is used with your network diagram template. So you normally, when you create the network diagram or when you access the network diagram template, it's a blank template like you would do with PowerPoint, just as an argument. Blank template that you then need to incorporate content on. And how are you incorporating content? Selecting the relevant icons or devices that you need to work with, and then naturally incorporating them on the actual template itself. So like I was saying before, you also have other programs like your a free draw, if I'm not mistaken. Let me see if I can access this content here. So the other software you can use is Smart. It's actually Smart Draw. So this is the other software that you can also incorporate. It's called Smart Draw, that then also enables you to create a basic network diagram functionality there. I think, Keegan, this also then re-answers the question that you asked earlier on. You can also use Smart Draw as a typical example of a package that you can use to create network diagrams. Although, like I said before, Visio would be preferable. This will still work without any distinctive issues there. All right, Graham, I hope that answers your question there. With activity 2, Keegan, you'll naturally need to then submit that separate diagram in Visio format. So for instance, it's not taking a screenshot of it. If you work with Visio, save that Visio file and then submit it also as part and parcel of your assignment. So you're not taking screenshots, you're actually submitting it as a separate document. And obviously the label would be question 2 there, or question 2.1 if I'm not mistaken. Question 2.1 and 2.2 would then obviously be associated with your submission. So ultimately, you could just mention activity 2 network diagram, and you're good to go. Obviously, then that would mean 2.3 and 2.4 would then go back to your Word document. Does that answer your question there, Keegan? Okay, cool. All right, sorted. So I think we can go back to that there. Okay, so we had mentioned that we want to also discuss topologies as far as today's session is concerned. I think you will also discover that this discussion will, to some extent, also assist with your assessment in terms of the actual design as far as your basic network there is concerned. So when we initially discussed networks, or when we introduced the whole concept of networks, I think one of the most important aspects that we identified or indicated was protocols. And remember, we mentioned that protocols are arguably those rules and procedures that govern communication within any given network. And ultimately, they provide some kind of universal platform that enables different architectural platforms to connect together without any distinctive issues. So it's sticking to a certain set of standards. So you could even argue that protocols are standards that make it a lot easier for the different manufacturers that are out there, the different institutions, the different organizations that are out there to create or design their own devices that will then work concurrently without any discrepancies with other devices that are manufactured by different organizations or institutions, because remember, they are sticking to a specific set standard to avail for proper connection and connectivity. So one of the other things that is also relevant when you discuss networks is the topologies, because topologies are the layout of a network. All right. So these topologies can either be physical or logical. So ultimately, if you look at what we've got here, we are looking at topologies, or a basic topology. And remember, a topology is the layout or the structure of your network. And this particular topology can either be physical, which is something that you can see. So the actual link between devices like your cabling, for instance. So your physical topology is what you can see, under how the actual topology seems. And then you also look at how that particular topology functions. And that's when you're discussing logical topology architectures. So logical looks at how it functions, and then your physical looks at how it seems. So if you want to look at it from a different perspective, the actual layout of the cables when you're discussing physical topologies, and then the way in which devices communicate is what logical topology infrastructures are all about. Now, it's important to understand what factors need to be put in place to typically lay out, or to typically look at choices of the different types of topologies that you'd use. Remember, there's a couple of topologies that are out there. What does it actually take for you to specifically choose maybe the ring topology over the bus topology over the star topology as a typical example? You need to take into consideration certain factors in terms of choices associated with your distinctive topologies. So let's put that as factors here for you to see. One of the most important factors is obviously the cost implication. How much is it going to cost to lay out this particular topology? So basic installation costs, initial installation costs, and obviously maintenance. Remember, when you look at any particular technological setup or any particular architecture, you've got initial costs that are associated with acquiring the equipment, and the cost that is also associated with installing that equipment. And then after that has been undertaken, there is also a need to have the appropriate maintenance associated with that distinctive installation there. I think we might even have used the systems development lifecycle as a typical example of what happens with what typically takes place. What are the phases or the stages associated with developing a system? And one of the last stages there is looking at a basic review. So once the system has been implemented, you look at reviewing that system and then ultimately also maintaining it, because that will always be part and parcel of the setup. In whichever way that you look at it. And then the other thing that you also want to discuss is scalability. All right. Remember, scalability looks at growth. And I think it's also pertinent when it comes to the assessment that you need to undertake in this particular instance, where they've mentioned at least some kind of future proofing, or it being as future proof as possible, which also looks at it being able to accommodate some kind of scalability. So when you're choosing a distinctive topology, you're looking at whether that particular topology has the actual capacity to grow and obviously meet your long-term needs. What are those long-term needs? Naturally, the ability to expand. If you need to add in new devices, if you need to add in, or if you need to accommodate for new staff, or for a large contingent of personnel that is going to be working within your environment, that's the topology that you've incorporated, or that's the topology that you've chosen or configured, accommodate for that distinctive growth. The other thing that you also want to discuss there is bandwidth capacity. So your bandwidth capacity is another element that you need to take into consideration, making sure that the actual topology that you've incorporated can accommodate for your speeds, or for your traffic or speed requirements. Remember, we've mentioned before that normally when you look at technological aspects of anything in terms of connectivity, you've got asynchronous and synchronous comms, where asynchronous normally has a higher download speed as compared to its upload. And normally when you're looking at synchronous comms, both upload and download speeds are typically one and the same. So it's imperative for you to understand that, okay, look, the topology that I've designed, can it accommodate for whatever requirements that I want to take into consideration, especially when you're looking at it from a speed or traffic point of view, where am I going to go with 20/20? Am I going to go with 50/50? Am I going to go with 100/100, depending on the kind of business that I'm configuring for? For instance, if you look at this particular instance, we've got a marketing company that deals with a lot of multimedia data. So ultimately, they'll need some kind of speed that can accommodate for that. And remember, the kind of topologies that you then need to put in place would need to meet those distinctive requirements. The other thing as well that you need to take into consideration when you're looking at basic choices of these particular topologies is the ease of installation. So ease of installation is another thing to take into consideration. What does it actually mean? You're looking at a scenario where you don't want to add in complexities that are actually, any kind of complexity has always been irrelevant, because it makes it a lot difficult for you to work with any distinctive setup. So technically, the easier it is for you to set up the network, the easier it will work, or the more chances you've got it to work the first time around. But once you install your network, or once you configure your network, you want to make sure that once that network is live, everything is running accordingly without any distinctive issues. So the easier the network is to install, the more likely that particular network is going to go right the first time. So this is important when it comes to basic choices. And then arguably, what works concurrently with ease of installation is naturally ease of troubleshooting. All right. So it's imperative for you to take into consideration there that if your network is easy to install, then it naturally is going to be easy to troubleshoot. And you also want to provide a scenario where, I think this also bleeds into everything, especially when you discuss even software design in terms of the apps and so on, that if you are the one who's designed an app and you're not available for an upgrade, or not available for maintenance, or not available for basic inspection dependent, someone else can still come through, look at your manual, and understand exactly what it is that you wanted to do, what it is that you were aiming to provide for as far as your actual app or software package is concerned. Same difference should apply when you look at your network design. Someone else can come through and have a quick look at what's happening as far as your initial installation is concerned, should be able to make sense of it, and then obviously make the necessary changes should the need arise there. So ultimately important for you to make sure that you understand specifically what's happening as far as the actual factors associated with choices, the different types of topologies that you choose. So you've got the cost implication, you've got scalability, you've got bandwidth capacity, ease of installation, and naturally ease of troubleshooting as well. So remember, you can also encounter hybrid networks, which are typically network configurations or network topologies that utilize or that incorporate more than one specific type of network topology there. So for instance, remember we mentioned the star, the ring, and the bus. Hybrid topology can be a combination of all three of those as far as specific setups they are concerned. And normally you find that in certain instances, topologies, most of these topologies do not exist as lone entities, because to provide for a more efficient kind of solution, hybrid networks typically need to be initially configured. So one of the first types of topologies that you'd want to discuss is the bus topology. We've looked at these before, but I think it's imperative just to revisit in order for you to understand specifically what's happening, especially with the assessment that we've just discussed. Now, your bus, remember, is any communications channel when you're looking at it from an ICT point of view. So a typical example of what a bus topology would look like is something that we've incorporated before with terminators at the ends there. You've got a link there. You've got another device there. And arguably, you've got another device connected there. So these devices can either be 1, 2, 3. And then remember, we've mentioned that to avoid what is called signal bounce, where a specific signal is sent across that one link or communications channel, and it reaches the end of the cable and it bounces back. Because what happens when it bounces back, it more or less keeps the network busy, or keeps the line busy when technically it's not. So to avoid those kind of discrepancies, you need to incorporate terminators right at the ends of the cable. So these terminators will then enable absorption of that signal to make sure that the line is free when it needs to be. So whenever a signal is sent across that particular network link, once it reaches the end of the cable, a terminator is responsible for absorbing that signal so that it doesn't bounce off the end of the cable and keep the line busy as far as your particular setup there is concerned. So normally this particular architecture associated with coaxial cabling, remember we mentioned that when you're looking at bounded architecture, you've got your copper and your fiber, and normally with your copper, you've got a subdivision of coaxial and twisted pair, and normally coaxial was the first type of or was the you could say it's typically the granddaddy of cabling when it comes to network infrastructures. And the reason why it's no longer really relevant when it comes to enterprise networking is it had massive resistance and obviously limitations in terms of speeds associated with basic connectivity there. So coaxial cabling, and normally with your coax, so basic topologies would typically be associated with coaxial cabling. And normally you might find with later day architectures, your bus topologies are also associated with the backbone. So you might want to even argue that if you're looking at an upgrade of what's happening as far as your actual cabling is concerned, these are now then used for backbone configurations or architectures. And ultimately, you had what they call British Naval connectors or BNC connectors that are then used to connect devices to the actual cable itself. And ultimately, you've got distinctive speeds associated with your setup. So more often than not, you might typically encounter certain speeds such as 10, or certain terminologies such as 10 base 2 and 10 base 5, for instance. Remember, the 10 represents the actual speed associated with your cabling. So normally 10 megabits per second. The base is the technology or the actual connectivity, which is baseband versus broadband. And then normally the 2 there would represent the type of cabling. So normally Cat or category 2 or category 5 dependent. Normally you find it labeled as 10 base T. So when you've got a T incorporated there, that actually indicates twisted pair cabling as far as your specific environments they are concerned. So your bus topology as well would then need to incorporate specific architectures in place to try and avoid the whole issue of collision, because remember, it's just one link or one line that is typically being used as far as your specific setup there is concerned. So to avoid collision, because remember, when your packets or your signals collide, they become useless and naturally or they become corrupted, and obviously when they become corrupted, they become useless. So ultimately, to accommodate for resending of these, or to accommodate for an indication or detection of this particular type of collision, a specific architecture was initially designed to avail for this particular type of topology to function with minimal issues as far as initial configuration is concerned. And that particular technology, like we mentioned before, is the SISMA CD. And remember, what this actually stands for is carrier sends multiple access with collision collision detection. All right, and what that actually means, the carrier sense part obviously means that that's mimicking or indicating the listening to the cable or the listening to the line before transmission. Multiple access means that you've got a multitude, obviously, of devices that are connected to that one distinctive link. And then the collision detection is the ability to identify a collision when it distinctively takes place. So when you look at what this actually signifies or means, your SISMA CD's main purpose. So it's actually just a basic a platform that typically manages conflicts. What are these conflicts when devices send simultaneously and then collision takes place? And how does it manage these conflicts? Obviously by detecting and preventing collisions. So what this typically means is, if you go back to the initial diagram that we had, assuming that whatever packets that 1 and 3 are sending have been typically have collided, ultimately you've got random wait states for each one of those devices. So these random wait states make it easier for probably a device 1 to then resend whatever signal or data it was initially sending, or for device 3 to then resend without the possibility of collision. So ultimately, when you're looking at it from as an example, let's assume that both these devices have sent data or have sent signals. These signals have collided, so that particular collision has been detected. Your random wait states could be in this particular format. As an argument, maybe device 1 needs to wait 0.3 seconds as an argument, and then device 3 would then need to wait maybe 0.7 seconds. All right. So already, what that typically means now is that if you've got different random wait states, the possibility of that data colliding again because of the simultaneous sending and receiving becomes minimized as far as your specific environment. So this is supposed to be seconds there. So this is just a typical example of what would typically happen. Obviously, that time might be a lot less or a lot larger, dependent on configurations, but it just gives you an idea of what actually takes place as far as the random wait states before transmitting again is well, because otherwise, if these wait states are the same, it means that they'll continue to send simultaneously and their particular data or signals will continue to collide. So you want to avoid that scenario by incorporating that distinctive or specific architecture as far as your particular setups there are concerned. So ultimately, the basic advantages that you find as far as your bus topology is concerned, quite inexpensive as far as basic installation is concerned. Obviously, especially looking at the whole concept of the coax that was initially used as far as your particular setup there is concerned. And in some instances, other literatures might want to argue that it actually works a bit better than basic smaller networks. On the other hand, if the cable breaks as a basic disadvantage, then the entirety of the network is distinctively nullified. And then again, you've got limitations in terms of the speed, like I was mentioning earlier on, of the 10 megabits per second as far as basic connectivity is concerned. And then sometimes certain breaks in the cable might be very difficult to identify or locate as far as your specific setup there is concerned. So another type of topology now that you also want to discuss is the ring topology. And as far as this particular topology is concerned, remember, this is when devices are connected in a continuous circular fashion as far as connectivity is concerned. And then ultimately, data or signals have to pass through each individual machine or each individual device until it reaches its defined destination as far as your particular setup is concerned. And then obviously, with your ring topology, you've got a single ring type of topology. And then you also have what they call a dual ring setup. All right, so single ring and dual ring. Obviously, when you're looking at it from basic perspectives, you can also even start discussing the whole concept of the token ring, which is something that is typically was initially designed to try and again avoid basic collisions as far as your particular setup is concerned. So if you were to look at it from a different point of view, you've got possibly something along these lines where you've got your 1, 2, 3, 4, and 5 being your devices, and then you also have your basic link between these devices there. All right? So dependent on configuration, your communication can either be clockwise or anti-clockwise in certain instances. So if you look at what this typically means is any communication. So if let's assume that our particular comms is in that direction. What it typically then means is if, for instance, device 1 is sending information to device 4, all right? It means that the packet has to go through 2, then go through 3 until it gets to device number 4. So sometimes you can argue the whole concept of security in certain instances. Why? Because those particular devices can actually get the comms that is dedicated between those two devices. Ultimately, another thing that you can also take into consideration is the fact that the more devices that you plug into the actual ring itself, the longer communications take now, because you've got more devices that need communication, or you've got more devices that have been plugged in. So it obviously means that those particular packets end up traversing multiple devices in order for them to reach their desired destination there. So ultimately, when you're looking at the whole concept of a token ring, all right, maybe just for you to get an idea of what's happening there. Let me see if I can maybe rub that out. When you look at the whole concept of what's happening as far as the actual token ring is concerned, remember, a token is more or less a packet that traverses the network as a specific permission to send or to utilize the network, if you want to look at it from a different perspective. So ultimately, when you're looking at what's happening with the token, all right? So we literally have a token that traverses the network, all right? That's our token, which is a packet normally, and any device that requires utilization of the network, or any device that needs to send signals or needs to send any data, needs to capture this token. And then once it captures the token, it means that every other device within the network cannot send the weight reception. So as an argument there, if we say our device number one is the one that has captured this token, all right, it means that ultimately devices 2, 3, 4, and 5 cannot send any information or data or signals at that particular point in time because they don't have the right or don't have the permission to send any to utilize any sending mechanisms as far as that particular infrastructure there is concerned. Only when one is done sending does it then release the token so that that specific token can then ultimately be captured by another device that might need utilization of the sending mechanisms put in place as far as the actual setup there is concerned. So it's imperative for you to understand the whole concept of the token ring architecture. And remember, we've mentioned that that particular representation there would be a basic packet that traverses the network, awaiting collection from a device that actually needs utilization of the distinctive network. And remember, token ring, if you remember well, when it comes to those access methods we've discussed before, it's the IEEE 802.5 standard. All right, as far as your specific setups they are concerned. So you can also have another setup. So this is just the typical example of what a single ring configuration would look like. Normally, when you look at a dual ring transmission, it's for redundancy, so that if one particular ring malfunctions, the other one can automatically take over. And ultimately, you might find that most of these. So if you look at the dual ring configuration, you have the same number of devices as an argument that then will have communication. Let's incorporate arrows to show where. So we've got something along these lines, and then you also have another ring going in an clockwise direction like that. And then obviously you've got your devices 1, 2, 3, 4, and typically 5 distinctively incorporated there. So this is a typical example of what a basic a dual ring would typically look like, normally associated with the fiber distributed data interface platform, and naturally associated with backbones for campus area networks, backbones for business environments. And in some instances, you can also even mention that normally associated with metropolitan area network configurations, although some literatures might want to say rarely, but you will also find some kind of fiber distributed data interface using these dual ring architectures within metropolitan area based configurations there. Some for redundancy, some for dedicated speeds dependent on configurations, because remember, you can use one ring to send, the other ring to receive, depending on basic configurations that you've got incorporated within your environments there. So some of the advantages associated with the ring topology is that you obviously are looking at less collisions. Obviously, communications become a bit more reliable. Locating problems or correcting these problems becomes a lot easier with the devices and an actual cable. No terminators obviously are needed in this particular environment, especially if you compare it to your bus topology environments there. But ultimately, the drawbacks would be if that particular ring is incorporated, obviously it requires more cable as compared to your bus environment, and then a break in the ring can then obviously then nullify the entirety as far as your network environments is concerned. And to some extent, equipment can also be a bit difficult to locate and be a bit expensive as far as generic setup there is concerned. On the other hand, if you look at one of the most common types of topologies that you'd find is the star topology. So this is one of the most common topologies that you'd find. Normally, you'll have a central device, such as your switch, for instance, that will then connect the multitude of devices that are incorporated within your network there. So you've got 1, 2, 3, and 4 representing your nodes or your basic devices that all converge at one distinctive point, which is obviously provided for by that a switch that is there. Ultimately easy for you to add in devices because all you have to do is just plug in and you're good to go. So for instance, if you're looking at a 24-port switch, you've plugged in maybe 10 devices there, you want to add another one. It's just a question of plugging in on the actual free port or available port, so whichever way you look at it. So as far as adding devices is concerned, quite easy when you look at growth of your specific network there. The only main discrepancy that you can typically discuss is the whole concept that if this central part malfunctions, then it obviously means that the entirety of the network is nullified. Although on the other hand, you've got at least a central management point as far as your network is concerned, because you've got that convergence environment. But the biggest issue is that if that particular setup malfunctions, then ultimately what it means, or if that particular device malfunctions, then it nullifies the entirety of the network. And then certain architectures have been put in place to try and accommodate for the way in which data is sent across, and that particular architecture is known as polling. You can go and look at some kind of research on this that then gives each device the permission again to distinctively ascend to avoid or to minimize collisions as far as your specific setup would go. You can also even talk about what they call extended star topologies there, where you now then probably connect that same network to another. Let's see if we can incorporate this appropriately. That connects to another centralized platform that then also connects to another multitude of devices. So this could be another switch there with devices 5, 6, and 7 incorporated. So this would be what you then mention as an extended star topology as far as your specific setup is concerned. So quite easy when it comes to expansion, quite simple. I think you might also discover that when it comes to your own environments, especially from the assessment point of view, star topologies become your default go-tos because they are a lot easier in terms of setup. They also accommodate for that growth should need be as far as your specific environments they are concerned. So quite simple and relevant as far as basic connectivity there is concerned. You will also encounter other types of topologies like your mesh topology, both on a bounded and a wireless architecture. The hybrid networks we've already discussed and understand exactly how they function in terms of basic configuration there. So what I would want you to do, that will also assist with what is happening with your basic assessments there, is looking at a research that that would ultimately look at your mesh topologies. So the mesh topology, typically more associated with wireless configurations there as far as your specific environments they are concerned. So look at the mesh topology, also discuss the whole concept of what is happening as far as contention in wireless-based networks. So you can discuss what the SISMA, CA this time. So instead of collision detection, we're looking at collision avoidance. And normally this is associated with wireless infrastructure, wireless technology, or wireless architectures. And then you can also look at the differences, because this is also relevant when it comes to your assignment as well. Ad hoc mode when it comes to wireless connectivity versus infrastructure mode. So ad hoc mode versus infrastructure mode. So obviously, this is normally associated with your wireless networks or wireless technology. when you're dealing with your access points, as far as your specific setup is concerned, or when you deal with peer-to-peer configurations within a wireless architecture, that's something that you also need to take into consideration as far as basic research there is concerned. I think, like I said before, hybrid networks are a given. I think what you might also want to then delve into as well is looking at what's happening with logical topologies. So go and research on this, and also look at what we've covered. Also look at the whole concept of what's happening as far as the discussion of your assessment there is concerned. But ultimately, this will then also enable you to appropriately conclude and find distinctive, relevant content and material for your assessment. As far as task 1 there is concerned. All right. Do we have any questions or contributions on this? Do you have any questions or contributions on this as far as content there is concerned? Questions, contributions, concerns from the floor? Ibuka, what's happening there?
So let's say we use Visual Studio now to design the network layouts.
You mean MS Visio, yes?
Yeah. So for submission purposes, can you just like take a screenshots of what you've done on
No, I think
Visio
that's,
and then just place it?
no, that's the same. I think that's the same question, if I'm not mistaken, that Keegan had initially asked. You'll need to then save your Visio file and submit that file separately. So you're not going to be taking screenshots of whichever program that you'd use, but you're going to save that file and submit it as an appendage. So you'll then just save it as activity 2, question 2.1 and 2.2. And then you can just say activity 2 network diagram and then submit that with your Word document as far as assessments would go.
Okay, I understand.
Okay, cool. All right. So any questions? Any other questions on this? So just to reiterate on.
I have a question.
Yes, Avelina.
How many devices we actually need to have in our diagram?
Well, as a minimum, already as a indication, you'll need to have 20 devices in terms of the desktops, laptops, and tablets. All right, as a minimum. But remember, those devices would then need connectivity. So you'll then need to add other devices that would include your switch, that would include your router, that would include your printers, that would then include your servers and your firewalls. You get it? So as a minimum, you need to make sure that the 20 devices that are accommodating for that growth, or that are accommodating for that future-proof setup, or that are accommodating for the expansion or scalability are incorporated. So the 20 only covers your laptops, your desktops, and your
tablets.
Tablets, exactly. And then after that, you'll then need to, because remember, it's an office space. So in that office, you'll then need to have a printer. You'll then need to have wireless access points. You'll then need to have your routers. You then need to have your switches you also need to incorporate your servers that then avail for those 20 devices to be connected, that then also avail for those 20 devices to communicate, that then also enable those 20 devices to connect to the internet or an external network.
Okay, so thank you.
All right, cool. Not a problem. All right, so there you have it. Do we have any other questions there? Don't forget to incorporate your firewalls as well for that diagram when you start incorporating content. All right. So any questions on this, or do we have other concerns, contributions from the floor there? Other concerns or contributions from the floor? All right, so what I'll do is I'm assuming the silence. I'm just seeing if I can get something. Is there someone who sent anything on chat? No. So I'm assuming that the silence is you being content. Let's see if we can start working on that assessment there, and then I'll upload the slides that we've just created here, and then this particular session, recording it as well. So once done, I will then upload it on YouTube. If you need to go through that content again, go through it, and then should you still have issues or questions or any concerns, just pop me a mail, and then we can attend to those accordingly. Right. Otherwise, if we are good to go, then I think we can call it a day. Let's stay safe, stay positive, keep smiling. We'll see you next week. Cheers. Lesedi and Graham, yes. Also, Graham, I think, like I said before, we will have a couple of face-to-face sessions scheduled from next week onwards, if I'm not mistaken, or from the second week of September onwards. So at least we can try and iron out any issues that you've got from a practical point of view. Then let's say yes, I'll upload the session on YouTube. I think a little later on. So yes, I will upload that one. Okay, sorted. All good, Graham. Stay safe. All right, Prashik, you good there?